Welcome to aminacademy.com. In physics, let us discuss about electric generators and motors. First, we will discuss about electric generators. Electric generators are machines that converts mechanical energy into electrical energy. A simple generator that produces an AC voltage or DC voltage. Regarding the component, the electric generator or an AC electric generator is a device that converts mechanical energy to electrical energy in the form of current or alternating EMF, electromagnetic force. In other words, the electric generator converts its kinetic energy into potential difference without violating the law of conservation of energy. Electric generators works on the principle of electromagnetic induction. Electric generator works on the principle of electromagnetic induction. The principle of electromagnetic induction states that the change in the magnetic field around a conductor generates electric current in the circuit. When a coil rotates in a magnetic field, a current is induced in the coil. When a coil of wire is rotated in a magnetic field, it cuts the magnetic field lines, which induces an electric current in the wire. This is because the moment of the wire creates a voltage difference. That is, the movement of the wire creates a voltage difference between the two ends of the wire, causing an electric charges to flow. That means an magnetic field line, when it cuts by a conductor, then it causing electric charges to flow. Depending upon the type of electricity produced in the electric generator is classified AC generator and DC generator. Then electric generators are mainly used to provide power supply to domestic lines, industrial purpose and commercial factories. Now let us discuss detail about working of an electric generator. Look at these equipments. This north and south pole in between armature, that is a coil wound around. Then it is to be rotated by external force. Now let us understand what is the working of the generator. A rectangular coil is placed between the two magnets. Let us assume that we are rotating the coil in a clockwise direction with the help of axles connected to the rings. On rotating the coil in a clockwise direction, AB arm will move upward and CD arm will move downwards. Like suppose one is AB and another one is CD. Now after half rotation, we see that CD will be on the left side and AB arm on the right side. Now applying Fleming's right hand rule to the CD arm, resulting in the current flowing from C to D, and using Fleming's left hand rule for the arm AB, the resulting current flow from A to B. Hence the current will enter B and the flow through B2. Thus, the direction of current changes after every rotation, resulting in producing the alternating current. That means every rotation, the direction of the current changes, so it's alternating current. Hence, the electric generator generally is also known as AC generator. If you want to produce DC, we will place a commutator between the rings. Commutator between the rings, it will change AC to DC. This is the explanation of the construction of working principle of electric generator. The above concept explains the electric generator in detail. If the next one, electric motor. What is electric motor? An electric motor is, before that we'll discuss some formulas for electric generator. That is EMF produced, that is equal 2 pi n ABF cos 2 pi ft, which means the induced EMF is depending on the number of rotation, RPM, N, and area of the coil A. This is N, rotation per minute of the solenoid. Then A equal area of cross section, area of the coil, cross section area of the coil, and B is magnetic field strength. Magnetic B is magnetic field, and T is time. How much time it's rotate, like T. So this is induced EMF formula. Next one we'll discuss about an electric motor. An electric motor is a machine that converts electrical energy into mechanical energy. Most electric motor operates through the interaction between the motor's magnetic field and electric current in a wire winding to generate force in the form of torque applied on the motor shaft. Here, electric motor form, the torque produced is N I A B sin theta. Here, N is RPM, rotation per minute. A is area of cross section of coil. B is magnetic field. Theta is angle between field lines and the perpendicular angle between theta is angle between field lines and the perpendicular to the and perpendicular to the plane of the coil and perpendicular to the plane of coil. An electric motor works on the principle of magnetic effects of current. Its principle is when a rectangular coil is placed in a magnetic field and current is passed through it, the coil rotates as a result of the forces acting on the coil. The following are the parts of the electric motor. First, DC power supply. DC power supply, it is a component in which the operating power source is generated. DC power supply. Commutator. The commutator, which means the direction of the electric source provided by the power source, is aided by this part of the electric motor. Rotor armature. It performs a continuous rotation while the motor is running. it is also there to aid the movement of the supply of electrical power to other parts of the motor and vehicle. Next is axle. What is axle here? Axle is an electric vehicle contains part of the main power source which provides one with the ability of direction of the vehicle through steering and gear uses, and that means that this after motor, this is the axle. Next is field magnet. A field magnet is within an electrical motor and it provides a magnetic field which enables the inner coil where within DC motor to rotate. The basic idea of an electric motor is really very simple. That means you put electricity into at one end of and a metal rod rotates at the other end, giving you the power to drive any machine. Now, further, the average torque formula. Average torque at the end of the axle is equal to constant into NIAB, where N is RPM, I is the current, A is area of the coil, and B is the magnetic field. And PD across armature. PD means potential difference. Across armature is equal line voltage minus back EMF. Therefore, armature current, next is armature current equal line voltage minus back EMF over armature resistance. Then power supplied. Power equal armature current into armature voltage. Into back EMF. And efficiency also you have to, efficiency percentage also you have to put. So far we discussed about electrical generator and electrical motor, some more detail. We have done. Please subscribe our YouTube channel.